Okay, in the last video, we finished with saying that you need to write your final answer as an ordered pair. And again, the left is asking what is y when x equals 3. And the right is answering, it's saying y is 2. So your ordered pair is 3, 2. Let's put this into action and do 2 more. Notice this is h of c, and this one is c. So it doesn't matter, we're just plugging in for c. So we're going to do h of c equals 2c minus 1 when c equals 1. So let's substitute 1 in. So we have h of 1 equals 2 times 1 minus 1. And just keep simplifying. Equals, my right-hand side, 2 times 1 is 2 minus 1 equals 1. So my ordered pair is 1, 1. Now let's plug in c equals negative 1. Again, always put in parentheses, h of negative 1 equals 2 times a negative 1 minus 1 equals 2 times negative 1 is negative 2 minus 1. Change it to add the opposite. Negative 2 plus a negative 1, same sign sum, is a negative 3. So my ordered pair is x of negative 1, y of negative 3. I want you to hit pause. I want you to try letter C. And in the meantime, I'm going to have the answers once you hit okay. So, okay, you hit pause. F of negative 24. After you substituted in, you had 1/4 times negative 24 in parentheses plus 1. Remember, when you're multiplying by a fourth, it's really dividing by 4. Negative 24 divided by 4 is negative 6 plus 1, which equals negative 5. So your ordered pair is negative 24, negative 5. And last but not least, f of 400 equals 1/4 times the quantity 400 plus 1. Again, you're dividing by 4, so this one's pretty simple. You get 100 plus 1, which equals 101. So your final ordered pair is 400, 101. And those are your answers. Our last one, we're just going to do a little bit more challenging of finding the function rule, which is the exact same thing as writing an equation. G of x right here is the same thing as y. So how do you get from 2 to 8 the same way you get from 4 to 16, same way you get from 5 to 20? Oh, you multiplied it times 4. So what did you do with your x? You did 4 times x. Instead of writing y equals your g of x. In this one, how do you get from x to y? Only again, y is your f of x. You know that it's a function. How do you get from 1 to negative 3 the same way you get from 2 to negative 2, the same way you get from 3 to negative 1? Oh, you did minus 4. So f of x equals x minus 4. Now this one is on your notes. Let's add it in here. We have, it's a little bit more challenging, in braces, we have in parentheses 0, comma, negative 2, 2, comma 4, negative 2, comma negative 8, 6, comma 16. Again, how do I get from x to y? How do I get from 0 to negative 2? Same way I get from 2 to 4. Same way I get from negative 2 to negative 8. Same way I get from 6 to 16. First, let's try out, well, from 0 to negative 2, I'd have to subtract 2. But that's not going to work here. So I tried subtraction. That's not going to work. What about multiplication? 0, well, 0 times anything is 0, so it can't be multiplication. What about division? Oh, well, that's not going to work with my 0 either. Plus 2 to 4, you have to multiply it by 2. What about addition? Oh, okay. 2 plus 2 is 4. Negative 2 plus, oh, it's not negative 8. If you go through all of these and they don't work, let's try 2 things. I always go to my biggest. Go to biggest. and say, what can I multiply x by to get close to y? What can I multiply 6 by to get close to 16? Well, what's 6 times 3? Well, that equals 18. That's pretty close. And then I asked myself, then what? How would I get to 16? Well, I would subtract 2, and that would give me 16. So what did I do? First I multiplied by 3, then I subtracted 2. Let's see if this works here. If I did -2 times 3, well, that'll give me -6. And if I subtract 2, that gives me -8. Let's try it here. 2 times 3 equals 6. Subtract 2, that gives me 4. Oh, I just need one more. 0 times 2, subtract equals 0. Subtract 2 equals -2. I found it. So this time, it's f of x. I had two things. I multiplied by 3. I did 3 times my x. Then I had to subtract 2. Again, if you ever find one that's not simple, ask yourself these two questions, and you will find it. Last but not least, we just have a little closer. And it says a student has a collection of baseball cards for several years. Suppose that B, the number of cards in the collection, can be described as a function of T, which is in time of year since the collection was started. Explain what each of the following equations would tell us about the number of cards in the collection over time. So just take a second and think about it. For this one here, well, the baseball cards would start with 200, and it would increase by 100 each year. Here, it starts with 100, and it would increase, because it's plus, by 200 each year. Here, they started with 2,000, and it's going down by 100 each year. Here, it started at 100, and it went down by 200 each year. You may now go ahead and start your homework.